some uses for Azure Spatial Anchors. There are multiple apps that you can create with Azure Spatial Anchors. A really good use case is anytime that you need to tie a specific information to a specific place. For example, if you're in a big building and if you want your users to find their way around, you can put breadcrumbs around and they can detect these spatial anchors and find their way. Another good use case is if you're in a big supermarket or a warehouse and it's really hard to know where things are, you can put specific product information to specific places. So when you're far away, you can see which way to go depending on your purpose. And these are all business use cases. For a more fun application, check out Minecraft Earth.
All right. So hi, everyone. I just want to take a minute to introduce myself. My name is Dino. I'm a software developer, mixed reality developer living and working in Germany. And today I want to be talking and working with you guys about XRTK, the Mixed Reality Toolkit, and how you can use it to develop cross-platform mixed reality applications and make your life a little bit easier instead of reinventing stuff that's already implemented by someone else. And for that, let's start with the website. So xrtk.io, that's where you wanna go and read up on all the info that you might need or that I didn't mention in this workshop. I'll do my best to cover all that's needed to get started right away. But if you're very curious, you can of course start browsing API references. And ultimately, something I always recommend, look at the source code, which is of course open source on GitHub, because that's where you can learn the most. Another information up front, this is a very much unscripted workshop, so feel free to post your questions anytime and I will try and answer them right away. Or if it doesn't fit into the moment, then we might I might answer it afterwards, but usually things will work very spontaneously. I'm not sure if I will be getting notifications, so I will have to check the chat every now and then for that.
I'll keep an eye on that, Dino. You just keep going.
Thank you very much, Simon. Yeah, when he's already joining us, I just want to introduce Simon as well really quickly. And Simon is, if you want, the founder of XRTK. He's one of the two guys that came up with it, and I joined as a contributor later on, and I've been contributing to the toolkit since then, developing a couple of features that were added. All right, so XRTK. The XRTK is, if you speak out loud, it's the same name as the MRTK. That's not coincidence. It's because the XRTK is it started out as the MRTK, but then at some point it got kind of forked. It was a fork, if you want so, and then they started in separate directions in some things. But you will notice that if you are familiar with MRTK, then you will have a head start with XRTK as well, because there is very, very similar and familiar concepts to both of them. So the XRTK, or Mixed Reality Toolkit, is a cross-platform toolkit for the Unity game engine that you can use to implement mixed reality applications. And compared to the MRTK, the XRTK puts more focus on the cross-platform aspect of things. So you will find that MRTK, well, there's been a lot of improvements here as well. The MRTK doesn't have as good cross-platform tooling as the XRTK. So you just have to compare both. Obviously, for HoloLens development, Windows Mixed Reality, the MRTK is a first-class citizen, but we also have in XRTK Windows Mixed Reality coverage, and you are able to use it. So let's start out by looking at the existing platforms. Each XRTK platform is its own NPM package, Unity package that you can install as a sort of extension to support that platform. So we have Core and SDK, which are general use packages that you will most likely need, except especially Core. And then we have, let's say you want to develop for Oculus, then you just add the Oculus package as well, and you have Oculus support. Same thing goes for Ultraleap and Windows Mixed Reality or Lumin, and so on and so forth. So getting started. To get XRTK into our project, there is multiple ways, but I personally find it the easiest to just add the scoped registry to my Unity project. So using the Unity Hub, we will now create a new project, a 3D template. Oh, let me switch the version above here. So officially, the XRTK is currently supporting 2019.4 long-term support release. That's this one. I'm personally using it already in a couple of projects with 2023, which so we are very close to actually updating the toolkit to officially support this version and drop support for this 2019.4. As you might know, there's a lot of things happening in between those two versions when it comes to a mixed reality development. A lot of the tooling has changed, so it makes sense to update at some point, so you're not stuck with a lot of technical debt. But for this workshop, just to be sure I don't run into any issues, I'm going to use the version that's officially supported by the toolkit as of now. If you want, you can also select 2023. I will use the 3D template. So the toolkit itself is not tied to any render pipeline. So you can use it obviously with Universal Render Pipeline or HD Render Pipeline. There is some materials in the toolkit that are they are based on the legacy pipeline, but you can just upgrade them if you are using Universal Render Pipeline. There is an option in the Unity editor to update materials, obviously. So I'm using Universal Render Pipeline in all of my projects is XRTK. So and that should work for you as well. So let's start out here by calling this XRTK Quickstart 2. I'm going to call it 2 because I already have one created, which is my backup project in case something doesn't work the way I wanted. Did I click? Yeah. So we are opening a new empty Unity project to add XRTK to. This could as well be an existing project you are working on. The steps will be the same mostly. If it's a not very complicated project, the integration should be really straightforward. Let me check chat real quick just to make sure.
We're all good, Dino.
Yeah. Okay. All right. So
I'm the same. Whenever I'm doing presentations on this at user groups, it's always waiting for Unity to open.
yeah, I was really I mean, one of the benefits of doing a recorded session is that you can cut out all of this loading, but we are good now. Okay. So this is a new empty Unity project. Same you will have if you create a new project, if you want to follow along. And now if you look at the package manager and we switch to, we just have Unity registry in project, the assets or assets and built-in package. So first thing we want to do is enable Unity to read from the XRTK scoped registry. For that, you just switch to your project settings, package manager, at least that's how I do it. And then this is where you can add scoped registries to your project. But take a look at the browser documentation, and then yeah, there's a lot of introduction stuff. Where's the snippet? Oh yeah, downloading XRTK. That's the one I was looking for. So here we can see in an image what you have to add. I think there is a copy. Yeah, so here we can copy it as well. This is the values we need. The name is actually not important, but usually I'll put XRTK. Then you will need the URL to the package server and the scope. And I actually add this manually. There is a seed Unity package that you can use to automate this. Then you just import it, but I usually just copy it. I don't know. I'm maybe a bit strange in that way, but I just like copying it.
I'm the same, Dino. A lot of times I will just use the Unity package, granted just testing, just to get it up and running. But yeah, this way is generally more efficient because you're managing it yourself.
Yeah, exactly. I like to be in control. So yeah, so we added XRTK, we added this, and we added the scope, and then we press save, and that's it. Let's go back to the package manager. I'm not sure, I might have to restart actually. Why wasn't it added?
Shouldn't do.
Why is it not added? Just a second. So let's take a look at another way we can do this. In your Unity project, there is a folder package manifest.json. Let's see if it was actually added. Yeah, so it was added. So why? Let's edit this.
My favorite phrase, because Unity.
Yeah. Okay. Now I think something happened. Yeah. So now you see. If this happens to you, please just open the manifest.json and make some edit and then undo it again, just to kick off Unity's file change detection, and
or just restart Unity.
Or just restart Unity. But I think in all cases except this one, this was actually working perfectly fine. So this is just because I'm doing a workshop. Unity is mocking me. So you can now select my registries, and ta-da! You will see all of the available XRTK packages. The current version is, I believe, let's say released version is 0.2. something, but there's already preview packages for the next update, and I recommend using those because there's a ton of new features and improvements there, and it's very close to being released anyways. So I'm using it in production as well already. Don't tell anybody. So I like to use the Meta Quest device, or the formerly known as Oculus Quest device, for showcasing. So I will just make sure to add xrtk.oculus, press install. And once again, grab your coffee and wait for a few seconds until Unity finishes importing it. As I mentioned earlier, this will work exactly this. So if you have an existing Unity project, just make sure to add the scope registry and then add the package.
You could check through the other packages, while we're waiting for that to report, because there's obviously the SDK and all the features.
Yeah. I actually made a. I was going to add SDK first. I kind of thought I already had. So the SDK package, which stands for Software Development Kit, I assume, is a package that has some out-of-the-box features or utilities that you can use, prefabs that you can use to get a head start. You can obviously create all of it on your own, and but you will see in a second why that's maybe not a good idea. Okay, so Oculus has installed, the package was imported. We need TextMesh Pro because some of the features used in the toolkit rely on TextMesh Pro. Yeah. All right. And also add SDK. I think it's already added as, no, it's not actually added as a dependency. So that's why we need to add it. But SDK has a dependency on XRTK core. So we are good here and don't have to add core manually. Okay. Oh, one more time. Are we done now? Okay. There is interestingly an update here available. So I think the dependency wasn't updated yet. So I will just make sure to update core to the latest. All right. Okay, we are done here. So we now have XRTK core installed and SDK. We will be talking about all of this in detail now, just to conclude. And Oculus. We are done in the package manager for now. And as soon as you have done that, you will notice that there is a new folder XRTK generated in your assets directory. This is the folder that contains all of the profiles and prefabs that were added, for example, by the SDK package, which you can then use to implement your own things. Generally, I don't recommend saving anything of your own into this generated folder, and also not making changes to these prefabs and files in here. You just use them as a starting point, and then you create your own variants of it and save them into your project directory for your own project, because this folder, you want to keep it as untouched as possible, so you can just update the toolkit as needed when you decide to update. Okay, so we now have the toolkit in our project, and we also have a new menu option, Mixed Reality Toolkit. Let's press configure here, and this should configure our sample scene to make use of the toolkit. This also made our sample scene, which is a default scene in a new Unity project, the base scene. XRTK works with additive scene loading, and it's the way that Unity also recommends to implement scene loading at this point. That means you don't unload your base scene ever. You just add new scenes on top of it. If you have done that previously, then I can show you what that actually looks like. Let's create another scene A. So this is basically multi-scene editing. I'm just doing it here in the editor, but it's working the same way when you are writing your own scripts. We have one scene here, and then we have another one here. So instead of unloading sample scene and then switching over to A, we add A on top of the sample scene. So we add it additively. Why I'm saying this is because you want to make sure that, oh, come on. Oh, come on, why are you? Okay, you want to make sure that your base scene is always at the 0 index position of your scenes in the build, because it's the scene that the toolkit that contains the toolkit, and that way the toolkit is always loaded first thing before any other of your scenes are loaded, and you can be sure that services and features are initialized and ready. Okay, so let me just real quick get my mouse up. I had put it to charge, and I'm not sure how I was even able to work without a mouse so far. With a touchpad, much better. Okay, so we have now everything ready. The toolkit is installed. Let's press play and see what happens. We shouldn't be getting any errors at this point. Yep, so we have a warning. Okay, that's fine. A new Visual Studio Etcher package is available. Great. And we have an OClose API version detected. That's also great. All right, so the toolkit is now installed and initialized, and everything is already working in the background. Obviously, our application is still empty, so not much is happening. But if I were now to press, for example, Shift, then we can see that I get a simulated hand, which makes use of the hand tracking implementation of the toolkit. And I can use this now in the editor to simulate pressing things, for example. We are still working on improving the how do you call it, developer tooling in the toolkit itself to make so you can move around and etc. without having to use an actual device. But I find myself, since Oculus Link was introduced, I'm actually almost never testing or like this. I just press play and then I use the device itself to interact with things. We will see that very shortly. But let's for now look at these game objects created. We have two objects that were created in our scene. One is the Mixed Reality Toolkit, which is the main service worker, or yeah, it's the service locator actually of the toolkit. It's also the only mono behavior it needs, and it will pass on all the relevant Unity events such as update loop, fixed update, disable, destroy. It will pass it to all of the subsystems that are part of that are registered to the toolkit. So that way you can implement your services and scripts without having to use a mono behavior yourself. That helps a lot with testing, for example, or keeping your code not as much tied to Unity itself as when you are working with plain mono behaviors. This root object contains all of our configurations. So if we want to change anything about XRTK, then this is the place to go. It's all the configuration, and also the root profile is here. The root profile, let's take a quick look, is a scriptable object asset in our asset folder. It's inside the generated folder. And as you can see here, the toolkit heavily relies on these profiles for its configuration. All of these profiles contain several options that you can change depending on your platform, maybe, or maybe you want to have a root profile for different use cases, so you can create multiple of those. Maybe you have a boundary system profile for Quest and another one for another platform, but actually you most likely won't have to do that because the root system profiles are designed in a way that they are kept cross-platform, where the actual platform specific stuff is happening that's inside the sub profiles, the data provider profiles. And let's now take a look and walk through all of these systems here so you have a good overview of what's included. The toolkit is now in our scene, and we have here first the mixed reality camera system. So you can decide whether you want to use it or not. If you don't want to use it, then you can just select it and remove it, for example. That way, the camera system is gone and you are free to implement your own camera implementation the way you want it. I recommend keeping it because the camera system is kind of essential. It's very some of this other systems are relying on the camera system being available. So I just suggest keeping it in there if you don't have a good reason to remove it. The camera system is also the one that created this XR camera rig for us, which is very convenient. If we click on this just real quick, we can see that this is our camera rig game object. It's where our it's the player's local tracking space, play space. That's how it was called formerly. And you can see here we have we have the rig transform, which is the object itself. The camera is parented to it. And then the camera itself also has another raycasting camera, but that's essentially it. This is nothing extraordinary. If you have used other toolkits, for example, the Oculus integration, it's very similar. The camera rig is always an object that wraps the camera itself, because you never want to move this object yourself, actually. So this was created by the camera system for us. And if we now click this camera system, then we can see it opens automatically all the configurations that are available for the camera system. They might be folded away, so you can unfold them here. As you can see, we have a global camera profile again here, which we can then open by double clicking. And then there is some platform specific settings, like what's the tracking origin mode, should the camera persist across scenes, camera rig type. Here you can implement your own camera rig type if you want. So if you create a script and implement Mixed Reality camera rig, then it will appear in this selection here, and you can make XRTK use your own script instead of this default camera rig. But that's an obviously advanced use case. So far, I haven't had a reason to do that, actually. So let's go back in here, and yeah, there is some settings here for transparent display settings and opaque display settings. So when you essentially, whether you are using a VR headset or a mixed reality headset like the HoloLens, for example, then we can apply different settings here. You can also decide to not have the toolkit change any of your quality settings by unchecking this checkbox, and that's what I usually do, because I like to do that on my own. I don't want the toolkit to reset any of my quality settings, because it can confuse you later on when things don't look the way you expect them to look like. So this is another profile, and there is a default camera provider which we can use, and it's all there by default. This is the out-of-the-box experience, and you can use these to override some of the settings in the global configuration. So the camera system is essentially really just there to manage your camera rig and give other modules access to the rig transform, camera configuration, and so on. Now, next is the mixed reality input system, which, I mean, it's obvious is responsible for input. By the way, you can unfold these as well if you want to take a closer look at what it looks like. You could be changing the name of the entry, and also you can here see the instance type. Again, like with any of the other modules, you can see that by implementing mixed reality system, we can create types that will appear in this drop-down selection here. So for example, the networking system, it's not part of the default configuration, right? So that's why it's still showing up here. I could be adding it using this plus, and then it will show up here, and I can add the mixed reality networking system, and it will be initialized to the toolkit. But I haven't used that system, to be honest, yet. I'm not sure what it's doing, but there's probably a good reason it's not part of the default configuration. So let's remove it again. Yeah, so the mixed reality input system has, again, its own profile. If we fold this back up and then we click here, then we open that profile. And this is where things get interesting, because compared to the camera system, the input system is, of course, much more, I don't want to say complicated, but it has a lot of more options, because this system is responsible for handling input and providing input options for the application to use. This is where we define what we call input actions, which are actions that you define for your project that could be happening, like, I don't know, fire or duck or jump and so on, or open the menu. So let's look at input actions profile. If we double click this again, then we can see that there is some predefined input actions here. Like select, which is like the main select action. We have hold, manipulate. It's really just some default input actions that many projects will make use of, but you're free to add your own. Like, for example, you could add a jump input action, and then you have to select what kind of input action it is. Is it digital? That means it's either on or off. It's either pressed or not pressed. It can be single axis, which means we get a value in between 0 and 1 in range 0, 1. This is for triggers, for example. How far is the trigger pressed? And that way we can implement some code that maybe only triggers when the trigger has been pressed halfway through, and so on. But yeah, so in this case, we could be making a jump action that's single axis. And that means the more we press the trigger down, the higher we jump, for example. So we have now created this input action, and we will see very shortly how to map it to controller input. So let's go one step back up, and we are back into the input system profile. This is there's some more configuration you can do here, like defining voice commands and where they should voice detection should start or not as soon as the application launches, and so on. So you really want to make yourself familiar with these profiles, because they tell you what the toolkit can do and what not. So this is where you can configure everything. Then we have global hand settings, which are, as the name suggests, responsible for hand tracking. This is where you can define global settings for hand tracking, like how to render the hand, what the grip threshold is, when is the hand considered to be in a gripped state, grabbing something, for example, and when not. And then in the sub-services of this input system, we can also decide to override some of these settings. Let's take a real quick look at that. If you unfold this, I'm not sure why they are all closed by default, but it's not a big deal. You can just unfold them using these arrows. And in here, we can now see once again that we have a couple of services registered to the input system. It's like, you can really imagine like a tree with several branches, and each branch can then have branches of its own. And that's what's happening here. We have our root, which is here. It contains these branches, and then the input system itself again has a couple of data providers registers that are own branches of the input system. And the naming is what's confusing to people very often here. So it's, what is a data provider? It's just essentially a service again. All of this is just services, scripts that are performing a specific action or responsible for something specific, and they're just services. But we like to call them data providers here because they are providing data sorts of to the input system. The input system itself couldn't be working if it wasn't provided by data from these data providers. So let's take a look at, I'm actually just noticing that I haven't imported so if this happens, then you can select an XRTK generated Oculus profiles. There is a Oculus platform service configuration profile. And if you click on that, then you can select install platform service configuration. And this will update your root profile to include all the Oculus specific profiles, because I just noticed they were not added yet. So let's go back to input system. And as we can see now, we have Oculus controller data provider and Oculus hand controller data provider. These two entries were not included previously. They were now added because I pressed this button here, install platform service configuration inside the XRTK generated Oculus profiles folder. There should be a pop-up modal showing up after you import Oculus that asks you whether you want to import this, but in some cases, as of now, it didn't show up. So this is how you can fix it manually. Okay. And why was this useful? It's because it took care of for us of registering all the providers. And this is also, as you can see, how things are essentially working. So our input system is a general use system, and we added Oculus support simply by adding providers that are capable of reading platform-specific data and providing it to the input system in a platform agnostic data package, wrapper package if you want. So it will read platform APIs, it will prepare all the data, and then it will pass on that data to the input system so things can work. And if we look at the Oculus controller data provider, then we can see that it comes with a couple of controller configurations that we can use, like the Oculus Touch controller, this one here. And if we open that one now, this is the right one. So let's go for the right one. Right-hand controller mappings. And this is where you can now map your input actions to controller buttons. So if you remember, we created a jump input action, and it was a single axis input action. So we could be using this trigger, for example, because it's not digital. It has a press strength if you want, and we can also use this one here. So let's just switch to, let's use this button. It doesn't make much sense for jumping probably, but we will use it. So if you press here now, then we can see, oh yeah, I have my jump input action here. And I can now select this. And this means now that whenever this button is pressed, it will fire the input action jump that we have defined. And it's now up to other scripts, input handlers, to handle this and perform the actual jumping. And this way, you are not tying your input to any platform. It's just a bunch of actions that you have defined, and then you just have to do the controller mapping to make it work with any controller, actually. So now we have Oculus support, for example, but let's say someone is playing with this Oculus Remote, which I'm not sure of is still in use, actually, but this is a bad example because it doesn't have a single axis button. Let me go back. This was a bad idea. Let's take the OpenVR controller data provider. This one has more controllers. So here's the Windows Mixed Reality controller, motion controller. And this one also has a grip button. And now we can add our jump action here. And this means now we have on Oculus, it will work with this button, and on Windows Mixed Reality, it will also work with this button on that controller. Our application itself doesn't really care where the input action is coming from. It just cares about handling it. And the raising of the input action is done by the input system itself, by the controller. So, yep, that's how we configure input actions. I'm going to make a short break here and check the chat to make sure that I haven't missed any, because I know this.
We're all good, Dino.
Yeah.
Still managing it.
All right. Perfect. Thank you. Just making sure. I know you are taking care of it. Yeah. So this is the input system. We have seen camera system, input system. Now we will speed up a little bit. What's the boundary system? Well, obviously, again, as the name suggests, it's responsible for handling boundary updates. This is where you can configure. We have, again, Oculus Boundary Data Provider, which will read API, platform APIs and check, for example, where is the platform boundary that the user has defined by the Guardian. And then we can use that information, for example, to check whether the user is about to leave the boundary or how close he is to the boundary, and so on and so forth. So again, this is very similar. The system itself is platform agnostic, and then we can decide to implement several providers that are for specific platforms. In this case, we have only one, which is the Oculus Boundary Data Provider, and it's configured to run in the editor and on the Oculus platform. Editor is important here because of Oculus Link. If we didn't, if we want to use this with Oculus Link, then we have to make it run in the editor as well. Now, if you were to add boundary support for, let's say, the Windows Mixed Reality platform, then you would just need to add another data provider here, make sure it's implemented, and then configure it to run on Windows Universal Windows, and that's how you get support for boundaries. Of course, that data provider needs to adhere to a specific interface, which is the Mixed Reality Boundary Data Provider. So your class, your service needs to implement this interface so it can be registered as a service for the boundary system.
Actually, Dino, that one is already implemented within the Windows Mixed Reality package.
Yeah, I was just going to say that. I was just making an example. Thank you. It's because, yeah, it's just an example. Of course, you don't have to implement it on your own because, as we saw earlier, there is a XRTK Windows Mixed Reality package. And if I were to install this one, actually, let's just do that real quick. We are going to press install here again. Let's see if the modal shows up this time.
I love watching green progress bars in the morning.
Yay. Okay, so this time it worked, it seems. We found a new platform configuration. The package was added, and it's now asking us whether we want it to auto install into our configuration. So let's press yes, absolutely. And of course, there is something happening that let's ignore that for now. Let's see if it worked actually. Select the toolkit, boundary system. And it's here, Windows Mixed Reality Boundary System Data Provider. It was added, and we can now, oh, it doesn't have a profile. So this one doesn't come with a profile. It doesn't need any configuration. It's just added, and it's working now. It will be working if we run this now on a Windows Mixed Reality Universal Windows device. So let's go back here. We can also make sure we can see that Windows Mixed Reality Control Data Provider was also added. So things seem to be working here. The only one that I'm missing is actually the hand control data provider. But yeah, there is some issue here that I have to check later what's going on. And there is actually a Windows Mixed Reality hand. Oh yeah, I know what's happening. So we have merged those. There used to be a dedicated Windows Mixed Reality hand control data provider, but now it's all one data provider that's responsible for any kind of controller on that platform. And that's why this error was thrown. There must be some leftovers that are looking for that legacy data provider. This is also, as you can see here, if we want to say, oh, on Windows Mixed Reality, I want the hand grip threshold to be higher, like this, then we can do here, and this will essentially override whatever is configured as a global grip threshold. This is the global value that will be used by default, but if a platform decides to override it to put its own value, then you can do that here. And now to grab things, you will have to grab more tight on this platform. So going back to the root profile, if you have seen my talk yesterday about the locomotion system, then you are already familiar with the locomotion system. If you haven't, make sure to look it up on YouTube. It's available as a recorded session, and I was talking in detail about the locomotion system there. This system is responsible for helping you make your player move inside your world. It implements a couple of teleport providers and locomotion providers like smooth locomotion, blink, or instant teleport. This will have, it just works out of the box to actually, and it you can use it so your users can teleport. That works because if you look at the input system, for example, Oculus controller once again, then we can see that this thumbstick is configured to fire the teleport direction input action. And if we now go back to locomotion system, then we can actually see that the instant locomotion provider is listening for exactly that input action, teleport direction. And now if that button is pressed, that thumbstick is pushed, then it will raise the teleport direction input action, and this script will make sure to handle it and perform teleportation as needed. So that's one example of how these systems are essentially working together. Each is fulfilling a single responsibility, but they work together to make things work. So in this case, obviously, the locomotion system has a dependency on the input system. If you decide to remove the input system, then you will also have to remove the locomotion system because it will not work.
Or implement your own input system. Fully flexible, because you can write your own.
Yeah, or implement your own. So if you were to use, let's say, the new input system by Unity, then you can implement your own input system data provider here, or your own input system essentially, and make it work. Yeah, spatial awareness obviously is responsible for spatial mapping on HoloLens, for example. Let's take a look at the profile. Yeah, we have a Windows Mixed Reality Spatial Mesh Observer. This is reading platform data to get our spatial mesh data. Actually, can you guys still see me? I just noticed it's getting really dark. Yeah, it's okay, I think. Yeah, so this reads platform data from the HoloLens, and then you can use that to display and visualize a spatial mesh or have things collide with your physical world and make things look more integrated and immersive in that way. Also, again, comes with some general settings. Like, for example, by default, the mesh will not be displayed. You can decide to make it visible, or you can use it only for occlusion or collision, depends on your use case. Then we have the diagnostic systems. Is actually a system that's meant to be used during development. And once you are done with your application and you want to release it to stores or anywhere else, then you can just remove this system unless you specifically want it to be there, because, or you just leave it on manual start. If you set this to auto start, let's do that and press play. Then it will give you this handy little diagnostics window that's available at runtime. So when you are running on device, then you will be able to read console logs and frame data, memory usage. It will all tag along inside your viewport, so you can essentially debug while running the application and wearing the device. This is very useful. It's I tend to use these days the metrics HUD when working with Oculus Quest, because it will essentially give me a lot of the same information, and it's a platform native feature. But if you are on other platforms, then this window can come quite handy, especially since you get logs as well.
I suppose it's worth saying as well, this is also very extensible, so you can add your own things to this, because obviously the system has data providers for each of the bits of data it gets there, and you can always add your own, and they will just be available.
Yeah, thank you. Exactly. So once again, if you have some other diagnostics you want to have, then you just implement your own diagnostics data provider. So create a new service that implements this interface, and then you can add it down here, and it will start working and provide this additional diagnostics data to this diagnostic system. And that way you can extend it and add more data. Yes, so let's stop this right here. And one last profile we want to check is the additional service providers. If we look at that, it's actually, as the name suggests, just additional service providers. This is where you can register some of your own business logic that is not general XR systems, for example. You can actually implement, and that's what I do. I create almost all of my, wherever I can, I create my scripts as extension services to the XRTK, because that way I don't have to rely on mono behaviors or anything. We will see that very shortly. And I can register them with the toolkit. I can also create profiles for my own services. I have good examples for systems I have created this way are like a leaderboard system that provides leaderboard functionality, authentication system that manages authentication against backend services, or a scene system that manages transitioning in between scenes and making sure everything is the way the application needs it, and so on. So there's plenty of systems or features that you can implement as additional extensions to the XRTK. Whenever you are creating a new service, piece of business logic, then you have to ask yourself, does this really need to be a mono behavior? If not, then you can register it as a extension service. And the only situation where something has to be a mono behavior is actually when it's on the visual layer, when it's on the UI layer. So essentially, mono behaviors are just there for things that are visible in the scene. We all know it. That's how I've been working for a long time. You create some object and then you call it game controller or whatever. And it doesn't really have any visual representation. It's just there so we can attach our game controller script to it. And this is essentially what you don't want to do anymore. You want to keep your scene clean from these controllers and business logic scripts, and they are much better put into these registered providers here. And then you can separate business logic from the UI layer very easily. And make
I suppose that you can also say it's good for things like spawner systems or things like that, where they will interact with the scene, they will instantiate their own game objects, but they're just like any other service running in the background.
Yeah.
You can always reference the scene from a system if you need to, but again, it's what you need.
Yeah, exactly. And this is where the cross-platform aspect also comes into play, because when you are creating your controllers, you will start having specific pieces of code that should only run on Oculus or that should only run on Windows Universal and so on. So this is really where this comes in really handy. So you implement something and then you just tell the software, the toolkit, this should only ever run on Android. And then let's say I call this Android scene manager. Obviously, I don't have that type ready yet, but I could also now create an iOS scene manager script or whatever, and then make that one run on iOS. And this way, I really keep them separate. I'm not munching several platform-specific compiler directives or whatever into one script. Instead, I really have dedicated pieces of code that are running for a specific platform. And this comes in really, really handy when working cross-platform. I'm currently working on a big-scale project that's so far has only been using targeting Oculus, but now they are adding support for Pico as well and other platforms. And this is where it became quite obvious that using the Oculus integration, there is an issue because, yeah, it's just meant to be used on Oculus. And it's what happened when we added the toolkit to it, the XRTK, we were able to actually make use of these general use systems, and where needed, for example, for the Pico's platform, we just had to implement a Pico controller data provider, and kaboom, all of the input system was working with the Pico platform, and we just have one single data provider that is platform specific and reads platform data, and everything else stays cross-platform. So let me undo these examples here. Okay. Because they will throw errors if I were to press play. Yeah. So what should I mention as well before we look at some code? In your project settings, you will find that there is oh no, we haven't moved that yet. It's actually in the preferences. In the preferences, there is a new entry XRTK now. This is also where you can specify your start scene, so the sample scene. This has to be the scene where your toolkit is configured at, where the Mixed Reality Toolkit object lives. And also it has to be the scene that is at index 0. The toolkit will actually make sure of that. So if you specify a scene here, it will make sure that that scene is moved to the top of the build scenes list. And you can also change where the default path for generated profiles is. But you don't really want to change this unless you know what you're doing and you have a very good reason to. Exactly. So here's some additional settings that you will most likely never ever need. Yes. So I feel like this is a lot of information. So I'm just checking if there's any questions so far. Anything I should elaborate a little bit more?
Nope, nothing as yet, Dino.
Yeah.
Good to see a demonstration.
Yeah. All right. So let's recap. We installed the toolkit into our project. We imported it, we configured it, it's running here. So let's see how we can implement some interaction. So let's create a cube. I love cubes. So we created a new cube, default cube in Unity. Let's put it at height 1 meter and 2 meters away from the camera. So I should be seeing it like this. Let's make this 1.6. So now it's right in front of me, because the toolkit, by the way, is configured to by default assume the user is 1.6 meters in height. So, and that's where the camera will be at. See, if you select main camera here, then you can see 1.6. Obviously, when we are running, it will use APIs to read the user's actual height. But this is just an in-editor value we can use to simulate what's going on, because obviously our users will not be having their head on the floor unless the camera system is configured to have device tracking origin. If you set this to device, then we assume that the scene origin is where the device is and not where the floor is. Okay, so we created a cube, and now what we want to do is we want to make this cube spin when we press it. And how do we do that? I'm going to create another empty object. Let's call this spinning cube. This is really freehand, so I might also not know what I'm doing, but let's restore this. So I've wrapped the cube inside another object, and I will also move this collider to my root object instead of having it on the cube, because I really want the I want to interact with this parent object, and I want to make this cube rotate whenever I press this parent object. And where's the, oh, I had gizmos disabled. Okay. So now we have an object that has a collider. We need the collider so we can detect collision, so we can raycast and know when it's pressed. The input system relies on that. And we have a simple cube. So let's now go ahead and create a script. I will do what you never should do and create the script just inside on the root level of the assets folder. And I will call this spinning cube as well. Okay, and I will drag this onto my cube. And now it's attached to this object. Let's now edit the script. Yeah. Let's zoom in a little. Okay. So we will give this cube, for its animation, we will give it some speed, like this. It will be the speed it's rotating at, and we will also maybe yeah, where on which axis should be rotated actually. I will just use any. So if we add this update, we can now go ahead and do transform, rotate, vector 3 up, speed times time. Oh, I think I'm using an obsolete API. Yeah, sorry. And we have to specify it. No, we don't. Yeah, relative to, that's what I was looking for. Like this. So we want to rotate it in its local coordinate space and not in the global coordinate space. Okay. If we save this now, and press play, should actually start rotating. Yes, it does. So that's good. That was our first test. But what we actually want to rotate is not this root object. We want to rotate the cube itself. So transform cube. And then we want to rotate the cube. Okay. And we also actually don't only want to rotate this when it's pressed. So we will need an input action with mixed reality, and that's where the XRTK comes into play. Private mixed reality input action. We see the namespace was added here, and we will call that input action, and we will initialize it to none by default. So we have now added a serialized field that we can use, configure in the inspector. Let's save this step by step. Oh, come on. All right, so let's drag this cube here. So this will be the object we are rotating. This is the speed, and we also want it to rotate only when select has been pressed on it. Right. So how do we do that? There is a handy script we can use for that, which is called base input handler. It's coming. It's only available if you have imported the SDK. If you haven't imported the SDK, then let's try and open it. Then you will have to implement your own. It will just add a little bit of boilerplate code. You will have to implement all of this yourself, registering the object, etc. So make sure to add the SDK, and then you can just use base input handler, and then this will just make the object receive input events. And now we also need Mixed Reality. Is it like this? I keep forgetting the name. Yeah. So if we now implement Mixed Reality input handler here, so this one will make sure to register the game object with the input system so it can receive input events. And by adding this interface, we specify that we want to receive on input down and on input up. So if you are familiar with Unity, this might remind you about, I think it's called iPointer down handler in Unity. Yeah, so, and there's also an iPointer up handler in Unity. So very similar concept. Let's remove that again. And now we have one input down and we have one input up. And if event data mixed reality input action is the input action we are listening for. So if input down has been pressed and the input action that was actually pressed or performed is the one that we are configured to listen for in our spinning cube, then we will set private bool. We need a flag here, rotate, do rotate. And we will also only rotate. Oh man, I'm not used to working on this keyboard. If do rotate. Okay, so we will only rotate if do rotate is set to true. And if this is the case here, then we set do rotate to true. And we also let the input system know that we have used this event data it's consumed. That means at this point, it will not, other components can now check if the event has already been consumed using this used flag. That's important. If you have multiple objects that appear in the same row, then they might all of them, if they are all input handlers, they might all receive the on input down. But the first one who sets the use flag is the one that keeps it. And yeah, so this way you can make sure that not multiple components handle the same event like this.
But obviously, have multiple things that want to run on the same thing, you could.
Yeah, if you want, it's always, yeah, depends on your actual use case. That's right. Let me go ahead and turn the lights on. Okay. Okay, we have now set to rotate to true, and if event data make action if input 4 has been released, then we will do rotate false, and we don't care usually with on input up we don't really care to use it. We just care about registering that it has been released. Okay, so if I'm not mistaken, this should already be working. Yes. Okay. Let's try. Okay, I'm pressing shift to show up my hand, and if I now press the left mouse button to simulate on input down, then you can see that it starts spinning because the spinning cube script has received the input action select from the input system, and it starts spinning as soon as I select it. Okay, let's try and make this work on device. If you want to use Oculus Link, then you will have to make sure that you add the Oculus desktop package. It won't work without it, which is a Unity package. It's not XRTK. Oh, I'm sorry, I was confused here. I'm already using the new input system, the new XR platform SDK. So we have to remove that again. As you can see here, this one has been deprecated and it's not available in later versions anymore. So what we actually need is the Oculus XR plugin, which is the new plugin for Oculus. It's hard to keep track sometimes of all the changes that are happening with mixed reality development, but there is this new package now. Okay, so now one last thing, XR plugin management, we have to make sure that we check Oculus here. That means when we are on a PC or standalone editor in this case, then we can then it will initialize the Oculus runtime. And now let's see if my device is still running. Yes, if I press play now here, it's loading up Unity inside my headset now. My guarding is not set up correctly. That's why we are now kind of offset. But and also there is an error displayed, which means that we have an issue in our configuration. When you are using Oculus controller data provider, then you cannot use the OpenVR data provider. So make sure you don't have both of them if you are using the Oculus native controller. Let's try this again.
Yeah, it is one thing with the XRTK is it will do exactly as it's told. So if you enable multiple things at the same time, try to run multiple things at the same time. So
yeah,
just being careful to configure it to work on each platform how you want it to work.
Yeah,
I can see your hand, Dino.
Yeah, so this is now my real hand. It's I'm running on device now, and the toolkit is tracking my hand. And as you can see, we have it's working. I'm rotating the cube, and now the cool thing is if I switch to controllers, as soon as the native API is registered, there is a controller that's been activated. Oh, I believe my batteries are dead. Oh, come on. Just a second.
We've all been there. You get up for a session of Beat Saber and it's just not there.
Yeah. So I switched to using my left hand, and as you can see here, the controller has been detected, and automatically the hand tracking was disabled, and we are now using a controller. These what you are seeing are the default gizmos representing my controller's coordinate space. So, and if I now press this cube again using select, which is the trigger, we configured it to be this trigger right here. And if I do that, you can see that my cube is spinning. That's great. All right. So that's essentially how you can handle input using the toolkit.
Yes. The key point to get across there, Dino, is that for every platform you've enabled or set up on the system, this will now just run on. You've built your scene once, you've added one script and linked it to one interaction.
Yeah,
and now all platforms that the XRTK is available for it will now just work without any rework.
Exactly. There is zero platform specific code in here. This is just really this will work on any platform that is supported by the toolkit and that is added to the toolkit. The data providers are registered. So if I now just switch over here, if I switch to Windows Universal now, which I haven't installed to this editor version, but if I were to and I just switch to Universal Windows and I build this and deploy this to HoloLens or a Windows Mixed Reality VR headset, it will work exactly the same out of the box. I don't have to do anything to make it work on that platform. And that's the beauty of it. Yeah, so I'm looking at the time, and actually we are heading towards end of this session. So I want to make sure to just leave the last couple of minutes for Q&A and any questions that have come up, because I know it's a lot of information initially, especially for anyone who hasn't used the MRTK previously, because it's a whole new way of using Unity. You don't rely as heavily on mono behaviors, and you rely a lot of configuration profiles. And yeah, I want to make sure that everyone gets a chance to ask any questions, if there are any. I know the session, it will be recorded. Alexander will put it on YouTube later on after he edited it and added some cool intros and outros, I guess. So feel free to catch up there if you want. If I was too fast anywhere and you need to repeat, make sure to take a look at xrtk.io for a kickstart on installing the toolkit and getting it into your project, and also make sure that you look at the source code if you want to use specific features, because essentially how we are doing a lot of the things in here is how you want to do it in your project as well. So if you take a look at SDK, the base input handler, for example, how it's implemented, then it will give you an idea of how you can use that for your own systems and services and so on. So I really recommend looking at source code to get an advanced feeling for the toolkit. And all of this that I was showing today works out of the box the way it is. So you just install. If you install, let me switch this to my registries and remove this filter. So if I were now to install all of these, Lumin, Ultraleap as well, then that means my application is running out of the box on Lumin, Oculus, Ultraleap, and Windows Mixed Reality. I mean, obviously, Ultraleap is not a platform in a way like Windows Mixed Reality or Oculus, but this package will add Ultraleap hand tracking support and so on to your application. And yeah, you just get started like that, and you don't have to worry about any platform specifics. In a perfect world, you don't have to worry about any platform specifics because the toolkit already covers all of it for you. Of course, if you run into stuff that you need to make work, then you just implement the data providers and the toolkit will take care of the rest. Yeah, thanks, Simon. We have let me just copy this, copy link and go back here. We have a Discord for XRTK. Make sure to join the Discord if you are using the toolkit, because that's where you will get help and where we can discuss features you need or issues you are having. If there are not any more questions at this point, then I will just wrap up the session. Thanks for listening, and I hope I could pack some useful information into it and spark some interest into the toolkit. and I hope to see all of you in the Discord channel of XRTK, where we can talk about your application and help out each other in making really cool cross-platform applications for mixed reality. Thank you.